In this lesson, we're going to take a look at what the equation is for the volume of pyramids and cones. So go ahead and take a look at this warm-up. It says, these two solids have congruent bases and are the same height. How do the volumes of these two solids compare? Describe your reasoning. So basically, if we could take, if we were in class, I would take a pyramid and a prism that have the same height and congruent bases, and I would show you that you could put the pyramid inside the prism, and you would see that the pyramid does not fill up all the space inside the prism. So what that tells you is that do they have the same volume? No. What can we say? We can say that the pyramid has less volume. It is smaller. Okay. So what we want to do is we want to figure out what is the relationship between pyramids and prisms and cones and cylinders when they have the same base and the same height. Again, the relationship we're going to find is only true for if the pyramid and prism and cone and cylinder have the same base and the same height. So we're going to skip over the investigation in these notes. In class, you would see me take a pyramid and the prism and fill them up with water and compare the volumes in there. Same thing with the cone and cylinder. I would take a cone and cylinder that are the same height with the same base, fill the cone up with water, and what we would see is that in both of them, if you take the amount of water in the pyramid or the cone, you would need to fill it up 3 times in order to fill up the prism or cylinder. So what that gives us is the relationship, the pyramid cone volume conjecture, where it says if capital B is the area of the base of a pyramid or a cone, and H is the height of the solid, then the formula for the volume is V equals 1/3 times the area of the base times the height of the solid. So what we'll do is we'll use this equation to help us do some problems where we find the volume of cones or pyramids and or find missing dimensions of the cone or pyramid. So in this first example, it says find the volume of a regular hexagonal pyramid with a height of 8 centimeters. Each side of its base is 6 centimeters. So the first thing that we have is we need to recall what a regular hexagon is. A regular hexagon is where all the sides and angles are congruent. So we know that this is 6 centimeters, this is 6 centimeters, and so forth. Now, the next thing that we need to do is recall how to find the area of a hexagon. And if you remember from, I believe it was chapter 7, we saw that you can break a regular hexagon up into 6 equal lateral triangles. So we know that for each of these triangles, it's 6 centimeters and 6 centimeters. So to find the area of this base, we need to find the area of one triangle and then multiply it by 6. So remember, the area of a triangle is 1/2 times base times height. So you have 1/2 times the base of that triangle, which is 6. And then to find the height, we would need to break this up and find that height right there. And when we do that, that creates a 30, 60, 90 triangle. And we know that the short side of that triangle is 3 centimeters, which means that the long leg is going to be the square root of 2 times 3. So this would be 3 square roots of 2. And so our height of that triangle is 3 square roots of 2. We go ahead and multiply this. Half of 6 is 3. 3 times 3 is 9 square roots of 2. So the area of one triangle is 9 square roots of 2, but we want to know the area of the hexagon. And the area of the hexagon is made up of 6 of those. So 6 times 9 square roots of 2 is equal to 54 square roots of 2. So the area of the base is 54 square roots of 2. And we know that the volume of a pyramid is equal to 1/3 times the area of the base times the height. So we know that the area of the base is 54 square roots of 2, so 1/3 times 54 square roots of 2 times the height, which would be, in this case, 8. So 1/3 of 54 is going to be 18. So 18 square roots of 2 times 8. And then 18 times 8 is going to be 144 square roots of 2. So again, the 144 comes from 1/3 times 54 times 8. And so we know that the volume of this cylinder is 144 times the square root of 2 cubic centimeters. And that is how you use the volume formula for a pyramid to find the volume of a pyramid. The next example takes a look at what happens when we know the volume of a cone. We know the radius of the base is 3 inches, and we want to find out the height of the cone. So again, take into consideration that we're using the formula volume equals 1/3 times the area of the base times the height. We know that the base of a cone is a circle. So the volume of this cone is equal to 1/3 times pi times r squared times the height, and we're going to fill in what we know. We know the volume is 24 pi cubic inches, so we have 24 pi is equal to 1/3 times, the radius is 3, so we're going to have 3 squared, which is 9, times pi, and we're trying to find out what h is. 1/3 times 9 gives us 3, so we have 24 pi is equal to 3 pi times h. Divide by 3 pi on both sides. You find out that the height of this pyramid, or this cone, is equal to 8 inches. Finally, we have 2 more examples. We'll look at the first one and then talk about the second one. So in the first problem, or in that first extra example, it says find the volume of a cube with a cone removed from the center. The side of the cube, the diameter of the base of the circle, and the height of the cone all equal 6 centimeters. So it might be beneficial to draw a picture of what this looks like. If we were in class, we would demonstrate what this looks like with with 3-dimensional solids that we have in class. And so we have, and hold on, let me make these so that they're not filled in, so we can show what this looks like. So we have this cone, or this cube, and we are taking a cone, and essentially we're just cutting out that cone inside of it. So what we really want to do is we want to find out all the volume that's not taken out by the cone. So what we want to do is we want to find the volume of the cube and subtract the volume of the cone. And so we'll find those separately. So the volume of a cube is equal to the area of the base times the height. The area of the base is a square with sides of 6 centimeters long. So we have 6 times the height, which is also 6. So we have 6 cubed. So we have 36 times 6, which gives us 216 cubic centimeters. The volume of the cone is equal to 1/3 times pi r squared times the height. The radius of the cone is going to be 3. So we have 1/3 times 3 squared times pi times 6. And that gives us 1/3 times 9 is 3 times 6 is 18. So we have 18 pi cubic centimeters. So we have the volume of the cube and the volume of the cone, and we know we want to figure out the volume of the cube minus the cone. So that gives us 216 minus 18 pi cubic centimeters, and we're just going to leave that as our final answer in that form. So we're not going to type it in and round our answer. We're just going to leave it as our exact answer. And finally, I'm not going to go over this. We'll go over this in the notes here. We will go over it in class. If you're interested in seeing it, just ask me the next day in class. But what you're trying to do is it's asking, find the difference in volume between the Great Pyramid of Giza and the Pyramid of Kukulkan. Not sure exactly how to pronounce that. It's a pyramid in Mexico. So all you would do is find the volume of the pyramid in Egypt, and you would subtract and then you find the volume of the pyramid in Mexico, and you would take the bigger one minus small and find the difference. So go ahead and take a look at your homework. If you have any questions, make sure you email me, message me on Remind, or ask the next day in class.